Home class. Today I'm going to talk to you about isometric view. So previously we have discussed about orthographic view and and we talked about an isometric view to orthographic view. So now we are going to present something related to isometric view, which is from an orthographic view to this isometric projection. Alright, so what is isometric projection? Before we go to that, let me just explain to you the objective of this class. So today's objective is to describe the difference between the multi-view projection, which is the axonometric projection, the oblique projection, and the perspective projection. And then we are going to list the advantages of the multi-view projection, isometric view projection, and also the oblique view projection. And you can do this in your class. Okay, sketch an example of isometric cube, create an isometric drawing given by multiple views, use isometric axis to locate drawing points, draw the inclined and oblique surface. The oblique surface we will be presenting later on in another class, and draw an angle or the ellipse of an irregular curves of the isometric. So here are the trees of the projections. So if you look at the projections, we have two projections. One is the parallel projection, the other one is the perspective central projection. The focus of this class is more towards the parallel projections. The parallel projection means that your projections are in a 2D, rather than the perspective projection are focused on one point into a small points towards the outer layer of the point. The parallel projection, however, consists of two. The first one is the orthographic projection. The orthographic projection projects three views, but in this class we focus multi-views, which is the first angle view and the third angle view. There are second angle and fourth angle view, but we didn't consider into that in this class. The other one is the oblique, which is focused on the cabinet projection and the cavalier projection. This one we will talk about later on. Today we're just going to talk about the axonometric, which is the isometric projection, diametric projection, trimetric projection. And another one is called the auxiliary projection. So what is a projection method? The first projection method we focus on where the multi-view projection, where the views are from a straight line. So your projection of an object may have been from a front view angle, or side view angle, or top view angle. The other projection are called the axonometric projection, which is also known as the isometric projection, where you have an angle of 30 degrees by its side, and the angle of the projection is parallel to each other and perpendicular to the plane of the projection. So the plane of projection is basically perpendicular. So basically you are showing that all the views that they are in the multi-view projection. So we have done the multi-view projection. Now we are focusing on axonometric projection. Another projection that we're going to focus on is the oblique projection, which is the visual parallel to each other and oblique to the plane of the projection. This one we will focus on later on. The perspective is not covered in this class. There are three types of axonometric projection. The first one is isometric, which has equal foresighting. That means equal length between the left side and the right side, 30 degrees each side. Diametric has a different angle, which is 40 degrees and 10 degrees. On the left side 10 degrees, 40 degrees on the right side. Two different axis direction. The trimetric is also the same, but a short sighting, which is all three axis direction. There is a 25 degree and a 45 degree. I'll show you later on what I mean by it. Here it is. This is an isometric projection. You have a scale of 100 on each scale of length, width and height, but the angles are 30 degrees view from the center point here. The diametric projection, however, has only 100% and on the height and the front view because of the 10% angular, where the side view has a 50% of dia punya scale because of the 40% view. The trimetric, however, has a 100% on the front view, which is 25% angle, 90% on the side view, about 45% angle, and the height is 80%. Most of the time we are in this class, we are only covering the isometric scale, so you don't have to worry about this, but you should know what it is. So let's take a look at how isometric projection is visualized. Okay, say you have this figure right here. The first one is number 1, you focus on number 2 and number 3. So to draw the isometric projection, first of all you need to draw a straight line, okay, 90 degrees, 0 to 180 degrees straight line. The line then at the center has to be a 30 degree drawn using a scale ataupun your protractor. Draw using a protractor or your measuring scale or 30 degree angle, and then from there you can start 100% line width and 100% line depth, and then 100% line height from here. Once you have drawn that, you can start by drawing the number 1 first. Later on you start drawing number 2, and finally the number 3, which is the top view. Remember, the ISO line is always 30 degrees, so this is 30 degrees, this is also 30 degrees, this is 30 degrees as well, this is 30 degrees as well, this and this are the same. From the top you can see the views has to be about 45 degrees. The front side and the left side is a normal. Say you look at A, D and E. A here, you can see that the front side is from this A view, point view here. The left side, however, has a little bit of a tilted. Okay, so basically what you want to do is you want to draw a cube. That's what your first exercise for today's class is. A cube of 120 degrees on from the height to the front to the other side. So basically from the front you have C, B and D 120 degrees. From the side tilted you have 35 degrees or 30 degrees, but a tilted of C, D and E and A to the side. Okay, let's look at the 30, 90 and 150 degrees laying out. So from this is 0 degrees, you move a scale of 90 degrees, and then you project a 30 degrees and project 90 degrees upwards, and then another 150 degrees upwards. And then the projection scale can be used to draw the correct isometric projection. So taking out the isometric drawing, this is the projection, which is around 80% of the total projection, approximately 80% of the true size, but the isometric drawing has to be 100%. Okay, these are the two differences between the projection and the drawing. So basically you take about 80% of the true scale of isometric scale, but by drawing and a full size. So the isometric drawing, unlike the isometric projection, are drawn using full length measurement. The isometric drawing is 25% larger than the isometric projection. So making a 2 by 2 by 2 cube, first you need to consider the front, top and the right side. So start by constructing the line of the angle. So this is 120 degrees, 120 degrees and 120 degrees. Then you take this is an example of a cube. You take a 2 inch by 2 inch, and later on you draw the square shape. Okay, mark out the lines through the length needed. Use the actual length. So they project the right side function from information to the top of the unit. So this information here is projected from the bottom to the top. Once you have done this part, drawing this with a more harder pencils, okay, bolder pencils, you draw a 2-inch line straight up, and then another 120 degrees line upwards. That makes you all the darkened side the final lies of your drawing. For example, you take this is say an example of a. You can do this in the class, okay, by creating this view. Say this is the top view, and this is the front view, and then this is the top view. Or other way, the top view and the front view. First of all, you did the cube already. You finalized the cube. Lightly draw the overall dimensions of the box. Make sure you draw the 30-degree angle, and then you start by drawing the straight line, 120 degree angle by drawing this line, and then another 120 degree angle drawing this straight line. Now you have this line at 30 degree, a straight 90 degree line, 120 degree, 120 degree, and then you combine these two by applying the height of this, then you get the angles, the length of this to get the intersection of the angle. So once you have done completing that, you draw the other side. So in order for that, you start out by drawing you can either start from this side by drawing the C, and then to the B and to the A, and finally to the E and D, or you can also start from E, A, B and C line together and drawing this line, and finally you add this line at the bottom to represent your this B length, okay, and then finally you add the final design of the D here just to darken with the final line. Another way to do is by using a point reference. This is by applying an angular reference. Say you have these three front view, side view and a top view. So imagine you're going to draw an isometric view of these three. Where do you want to start with? First of all, you always draw the cube or a rectangular cube, okay, with a front and a top and a right side, like this one. Draw the overall outline of the drawing first. Take a straight line, draw a 30 degree and then another 30 degree, and then draw the third line straight. Once you have finished with the bottom line, you start out with a 120 degree, taking the top line, and another 120 degree for the right side line. Combining both of these together, this line and this line, to make a rectangular cube. Mark any reference of the point for the non-isometric surface. So any non-isometric surface, you draw it first. Draw the surface from the connecting, and the bottom one, if you remember this one, the 2.0 and 1.5. So take a 2.0 height, and then another 0.5, which is the non-isometric surface, and then you take a pencil and draw from this point to this point, and this point to this point. How do you obtain this line? It's the same parallel line as this 30 degrees. Alright. So make sure you have a T scale, okay, that will make your life easier. There is one more in isometric where you have some difficulties by drawing. So start with what you know. For example, an irregular object. Start with what you know by applying the square end first. Okay, take a large cube, then start drawing what you know first. For example, this isometric view, orthographic view. start from what you know, this one and this one. Now the rest you leave it as a section cut plane. Then draw the section using point reference. This is called a point reference, where you try to use a 30-degree line, okay, and sum it together to make a orthographic, from the orthographic to make a isometric drawing. Okay, this will take a bit of time to do. It requires your imagination, preferably higher imagination. So what you need to do is you need to divide the line, the isometric orthographic view into multiple lines. So say for this one you have 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 lines. So you divide 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. Aside from this final line here, all of them you have to take into this consideration the height from the surface, what the height is going to be. So from here you take a straight line and measure the height for each line. Okay, the curve is pretty difficult also, but the way to draw a curve, okay, same thing as what you do in the point reference line. You have to make sure that the A, B, C and D here correspond to what the diagram at the front view is. So take these A, B, C and D into the top view, locate the point of A, B, C and D. First locate the line length from this one, length of the line for each line, and then draw a simple softer line just by applying this A, B, C and D. Locate the point B, C and D, and then sketch with hand a smooth line from here until here. Okay. Finally, you take the drawing line vertical from point A to locate of point A prime, where you have the bottom one. You draw again a three-dimensional line to make sure that all is equal in height, and then draw a light curve downwards until it reaches to this side. So the equal length has to be equal on each line. The line of C must be equal. So then you get the shape of the final line. Now to draw another one is to draw a circle lies within the plane, which is not parallel to the plane. This is called an ellipse. It's very difficult for this one, but you have to remember always starts with the cube. So taking approximate ellipse size can be constructed by using a semicircle. Notice the circle is different from the radius. So basically what you need to do is to draw the line from here to here, a third angle line, a triangle line with the same. Okay, once you have drawn that, you can also draw from here to here another triangle. Now you have a point connecting this one, this one, this one and this one. This is the radius of the first circle, the second radius of the circle, and radius of another circle. So the first circle is this radius, and also this radius, as well as this radius. The other radius is this one, okay, this one, this radius here, and the rest you just copy with what you did previously, which is the R from this side. You take this radius here, you draw another line from here, and also take an R from here, you draw the line from here, another R from here to draw a line, and then you take the R here, you change the direction, move to here to draw this. This one you should have drawn here, right? So by taking the R here, you can draw the line from here. Alright, so let's look at it step by step. Start by creating a critical point where to put the needle and where to start the arc. So the midpoint of 60 degrees, you put the needle and you make sure you have a correct length of the correct length of rope or tali, okay, to sketch it. Then you have another sketch of the angle coming upwards. Place the needle again and let the land lines dictate the radius. Okay, you put a needle here to obtain the arc, as well as here to obtain this arc. And then another end point here, you put a needle to obtain this arc, as well as putting the point here to obtain this arc. Alright, that is your first. Do the same for both bottom and left, right. So that will give you an ellipse kind of shape. Okay, an ellipse kind of shape. Another one is called a saw thread. This one is pretty the same as the ellipse, but equally spaced at the symbol thread. So it can be used to represent a screw thread. So this one requires a this one is also another same thing as a parallel line. Okay, a parallel design, same thing, but multiple, right? Multiple. The arc as well requires you to understand where the radius and diameter as well. So draw this arc here by using the same configuration as you did when drawing the ellipses. Okay, remember the ellipse? This is what we did as well, right? Now to draw an isometric sectioning, for example a full section, you require at least a 60-degree angle of the cross hatching. Remember the cross hatching that we talked about? Yep, that's the 60 degrees plane line. Make sure if you have both lines, say this one is a half view, you have to have at least both 60 degree against one another of the cross hatching. Okay. The other isometric dimensions that you need to think about is let's take a look at some of the correct and incorrect one. So this one is parallel. Okay, the lines are parallel. Whereas this one, you have a mistake because the line is basically not parallel to the ones that you have drawn previously, which is this line. It is more like a diagonal line, which is not. This is not correct. And this one, if you look at it, it's more. The dimensions are in the same straight line as this first line of the cube. Okay, so make sure you practice. A lot of practice makes you better. Okay, make sure you practice all of this. Draw this figure, this isometric line, because this is very important for your later skills. Okay, make sure you draw it and understand it thoroughly. Alright, so that's all for this class. Thank you very much for listening.